Good morning children, this is Latha. Welcome to class 7 IIT Physics class. Children, what we are doing? We are discussing vector law of addition. Is it no? Vector law of addition. So what is vector law of addition? So whenever a quantity is a vector quantity, what are the things it must follow? It must obey. A quantity, if it is a vector quantity, it must have a magnitude unit, and second is direction, and third is it must obey the laws of vector addition. Okay na children, there are some quantities which are having direction but they are not vector quantity. Current, is it no? There are some quantities which are having magnitude and unit and direction, but they are not vector quantities. The reason is they are not obeying the laws of vector addition. So a quantity, when it is having magnitude unit, direction and must obeys the laws of vector addition, then only it is a vector quantity. Is it no? So next, vector law of addition is what? We saw basic rules of vector addition in the first class. Then second class we saw that there are two laws of vector addition. First is triangular law of vector addition and second is parallelogram law of vector addition. Triangular law of vector addition we already discussed, and today we will see parallelogram law of vector addition. Is it no? So first once we will revise the triangular law of vector addition. So see children, suppose there are two vector quantities, A vector and there is one B vector. Okay, there are two vectors, A vector and B vector. B vector makes angle theta with the horizontal and A vector, horizontal vector. Okay, we know that when two or more vectors acts on a single point, they combine and form a single vector. Is it no? Suppose two or more forces acts on a same point, they combine and form a single force, single vector. This process is known as vector addition. Clear? So here there a triangular law of vector addition only for two vectors only. When we add two vectors, that time only we use triangular law of vector addition. So first vector is A vector, second vector is B vector. Now you have to add them by triangular law of vector addition. So how to add? A vector plus B vector gives what? R vector. Is it or not? A vector and B vector, when you combine, it gives you R vector. What is R vector? R vector is a resultant vector. Okay, now I explain. Now I don't know, whenever two or more vectors acts on a same point, they combine and form a single vector. That single vector is known as resultant vector. Clear? So A vector plus B vector is equal to R vector. Now geometrically how to add them? See, A vector like this, A vector. Okay, then after B vector like this is there, directly like this we will keep. We know that parallel shift of vectors are allowed. We shifted parallel, is it? This one like this we shifted. Parallel shift of vectors are allowed. So it makes theta angle with the horizontal. Is it not? B vector. So you see both the vectors are acting as the two sides of a triangle, and how they are combined, they are in the same order. See, A vector like this going, B vector like this going. So they are following the same order. See, like this one and like this. A vector is going like this, B vector going like this. They are following in same order. Is it? So when two vectors acts as a two sides of a triangle and they follow same order. Once again, when two vectors, okay, A vector, B vector, they acts as a same two sides of a triangle, two sides of first side, second side, two sides of a triangle, and they follow same order. that time the resultant vector, what is the resultant vector? The third side of the triangle. The third side of the triangle is a resultant vector. Okay, and what is this a resultant vector? What is its magnitude? Its magnitude is the length of the third side. Length of the third side is a magnitude of resultant vector. Magnitude of resultant vector is the length of the third side. Okay. Now next is direction. What is its direction? Direction is, see, here two vectors are in same order, but resultant vector should be in the different order. So if you will give the resultant vector direction like this, A like this, B like this, and resultant like this, then resultant vector also will come in same order. But resultant vector should not be in the same order. Resultant vector should be in the opposite order. That is what triangular law of vector addition. According to triangular law of vector addition, the two vectors which should be added, A vector, B vector, the two vectors which should be added acts as a two sides of a triangle in same order. See, same order. Then the resultant vector is the third side of the triangle in different order. So see, B is going like this now, and resultant is going is like this, different order. Next is the angle it makes with the A vector, alpha. What is that? Alpha is the angle with respect to vector A. Clear, children? This is triangular law of vector addition. Then we will see parallelogram law of vector addition. Clear? So see, children, now we start today's topic. Today's topic is parallelogram law of vector addition, triangular law of vector addition, first law, and second is parallelogram law of vector addition. So this one we will see now. Suppose there is an object. This object is there. It is tied by two threads. Okay, and from this side one person is pulling it, and from this side another person is pulling it. Pulling means what? Applying force. Is it? So force is what? Vector quantity. So two vectors are acting on same particle. Is it? No. A vector, B vector. From here one person is pulling this box with some force. From here also second person is pulling that box with some force. So two vectors are acting on same particle. So now what is the resultant? How the box will move? Once think it. If the person A is applying more force than B, then of course box will move. Okay, box will go surely from the middle only. Okay, the resultant vector will be like this. Is it or not? Box will move front, but middle only will go. But if the A vector, first person applying more force, so little that side will go. If B vector is more, means second person is applying more force, so little this side will go. But if both are applying same equal number of force, box will go exactly from the middle. That is called resultant vector. Okay now children. So here both the forces, both the vectors are acting on same point and they combine and form a single vector, that is called resultant vector. R vector, box is moving front from the middle. Okay. So this is a concept. Now see, suppose A vector, this is a A vector, first vector to be combined, and second vector is a B vector. Okay, makes angle theta with the horizontal. These two vectors you have to add, A vector and B vector you have to add by parallelogram law of vector addition. So when we add two vectors, A vector plus B vector, what we get? R vector. What is R vector? Resultant vector. When two or more vectors combine, they form a single vector, that is called resultant vectors. Resultant vector. Okay, see children, now we will add. Now you see a vector, first vector, and second is b vector. Parallel shift of the vector, already said parallel shift of vectors are allowed. Parallel shift for vectors are allowed. B vector parallelly we shifted, makes angle theta with the horizontal. Clear? So a vector, b vector, we have to add angle between them is a theta. Now you see the vectors, how they are tail to tail, they are added. This is point of intersection. Remember in triangular law, okay, in triangular law, how a vector, if a vector is like this, then b vector is like this. Is it not? Like this a vector, b vector like this. Same order they are going. Is it or not? Like this one is like this. But in parallelogram, how they are added? See, tail to tail, point of intersection is here. This is a difference. This is triangular law, this is a parallelogram law. Okay, tail to tail they are added, point of intersection here. But here same order. Okay, these things, these are the things you must observe. You must see the difference. Okay, so now you have to see what is a resultant vector. Okay, a vector, b vector added, tail to tail, angle between them is theta. Now, what is the resultant vector? So, resultant vector is a diagonal, the common diagonal. This is resultant vector, the common diagonal of this parallelogram. This acts as a parallelogram. Okay, now R vector is a diagonal. Okay, diagonal of this parallelogram makes angle alpha with the A vector. So R vector is a resultant vector. Now here R vector magnitude. What is the magnitude? Length of common diagonal. The magnitude of resultant vector is what? Length of this diagonal. And what is the direction? Alpha, angle alpha with respect to A vector, first vector, angle alpha with respect to first vector, alpha. Okay, this is what? Direction. Clear? Now we see the definition. Okay, before going to definition, please children note down this. Once again I am saying, pause the video when you are writing the notes. Pause the video, write what is given on the board, then continue the video. You must give the heading, chapter name, subject, class, date, time, subject, heading, what is today's parallelogram, law of vector addition. Then write it neatly. If there is a diagram, please draw with pencil, use scale. Neatly you have to maintain your notes. Over this. So, see children, the definition, parallelogram law of vector addition. If two vectors are represented by two adjacent sides of parallelogram. Okay, in triangular law, the two vectors which should be added acts as two sides of triangle. Just like that, here also two vectors, the two vectors are what? The two vectors are what? Two adjacent sides of parallelogram. See, what are the two vectors? A vector, B vector. Both are two adjacent sides of parallelogram or not? Okay. In magnitude and direction, they join by what? Tail to tail. This vector, okay, this vector tail is this, and this vector tail is this. Okay, A vector tail is this, B vector tail is this. So join tail to tail. Clear? Then the resultant is given by diagonal of parallelogram. This is a parallelogram. Means diagonal is what is diagonal? Diagonal is the side. Okay, diagonal is a what? It's a side which join the opposite vertices. This vertex, both are opposite to each other. So line segment joining these opposite vertices is known as diagonal. So the resultant vector is what? Diagonal. Okay, diagonal of parallelogram. What is the resultant vector? Diagonal of the parallelogram in magnitude and direction starting from common intersection of two vectors. What is a common intersection? This is common intersection of two vectors. A vector, B vector. Common intersection point is this. From here it started like this, it is going. This is the direction. Okay, direction is like this of resultant vector. So the reason what is A vector and B vector are combined and form what? R vector. What is R vector? Resultant vector. What is its magnitude? Length of diagonal. And what is its direction? Starting from the common point. Okay, it makes alpha angle with the A vector. Alpha angle with the A vector. Clear? That is what? Direction. Now children, please note down this neatly. Must draw and write this also. The definition. Write down. See children, this is a question based on parallelogram law of vector addition. Question is two forces. There are two forces. One is 3 Newton force. Second is 4 Newton force. Two forces means two vectors acting at a same point such that angle between them is 60 degree. You have to find the resultant force. So two forces are acting on a same point. Okay, so two forces, one is 3 Newton, second is 4 Newton. Both are acting on a same point. Angle between them is 60 degree. Clear? So here we will apply parallelogram law of vector addition. These two forces we will consider as the adjacent sides of parallelogram. It's a parallelogram. Its adjacent sides are the two vectors. That is 3 Newton force, 4 Newton force. Two vectors act as the adjacent sides of parallelogram. Okay, how they are joined? Tail to tail. They join tail to tail and the angle between them is 60 degree. Now, what is the resultant vector? When we add resultant vector will be the diagonal of the parallelogram. So this is a diagonal. This is the diagonal of the parallelogram. The length of this diagonal is a magnitude of resultant vector. And direction is Q with 4 Newton. Q is what? This angle. Angle of between resultant with the first vector. This is a Q. That is a direction. Okay, so we have A vector plus B vector equal to R vector. The magnitude of resultant vector we can get it from the formula. You have to remember the formula. Geometrical method if you will use, you can find the length of diagonal, then that is a magnitude of resultant vector. Analytic method is what? You have to use the formula. Square root of a square plus b square plus 2ab cos theta. So first vector A is 3 Newton, so 3 square, B second vector 4 Newton, 4 square plus 2AB, 2 into 3 into 4 into cos theta, cos 60 degree, angle between them is what? 60 degrees, so cos 60 degree. 3 square 9, 4 square 16, 2 into 3 6, 4 jar 24, cos 60 value half. So we can cancel 2 12 jar, okay. Now when we calculate overall, we will get root 37 units, that is value is 6.08 Newton. Okay, so this values you can find out by tables will be there. By seeing that table we can find out value is 6.08 Newton. Direction you can find by 10 Q. Q is what? Here the angle resultant vector makes with the first vector, that is Q angle. So 10 Q is equal to A sin P by B plus A cos Q. What is P? P is this angle. Okay, and Q is this angle. So A sin P by B plus A cos Q. So write down children. This is the parallelogram law of vector addition today we discussed. I hope you are following the class. If you have any doubt, please post your doubt as comment. I will answer it. Thanks for watching.